All right, let's go over this worksheet. It says identify the sets to which each of the following numbers belongs by marking an X in the appropriate boxes. Now, we're not going to do the entire worksheet, but we're just going to pick a few of them and kind of go over them. So, as a reminder, our natural numbers are just our positive whole numbers. No fraction, no decimal. We classify our whole numbers to include 0. So natural numbers are only the positives, whole numbers allowed to have 0. The integers, they can also be negative now. So it's our positive, negative whole numbers including 0. A rational number is a number that we can make into a fraction. It could also be positive or negative. Now you could also convert decimals into fractions, right? 0.1 is the same as 1/10. So if it's not repeating, you can convert a decimal into a fraction. And then an irrational number is any decimal number that you can't convert into a fraction. And you typically see this with like pi or like a square root of 2 that can't like reduce. Those are going to be irrational numbers. If I had a repeating decimal like 1/7 and then that 7 was repeating, I can't turn that into a fraction, and so therefore it's going to be irrational. And then a real number, that's going to be any number that is definable in the real plane. So first it has to be definable. So if you have an undefined number, that doesn't count. And then it has to be in the real plane, which means no imaginary number. So if we have an I, like a negative inside of a square root, it's not a real number. If you're dividing by 0, it's not a real number. So in this first one where it says negative square root of 17, it's not a positive whole number. It doesn't include 0. It's not an integer because those are all the whole numbers, so immediately you can't do it. Now, if I enter the calculator square root of 17, I get this repeating decimal, so therefore it has to be irrational. It is definable, so therefore it's going to be a real number. -2, it's not a natural number, it's not a whole number, because those can only be positive or 0. It is an integer, because they're allowed to be negative. It's rational, because I can turn it into a fraction, -2/1. Now, for rational and irrational, it's only one or the other. So if you know it's rational, you don't even have to think about it being irrational. And then it's a real number because it's definable. 0, it's a whole number because I can include 0 in my whole numbers. It's an integer. It's rational. I could say 0/1. So it's a rational number and it's real. Number 5, -6.06. It's not a natural number, it's not a whole number, and it's not an integer because those can only be whole numbers. Now it's a decimal, but I can convert that decimal into a fraction. If I make that over 1 and I move that decimal over, you just add zeros on the bottom. So it's -606/100. So it is a rational number. Now, a secret is, if it's repeating, it's not going to be a rational number. So because the decimal wasn't repeating, I can do that. And then it's real. Now for number 6, because it has that repeating decimal, that's what that little bar on top means. It means it goes on forever. It means it's irrational. It's still a real number. When it has this ... it means it's repeating. Therefore, it's irrational. For number 9, it's dividing by 0. So therefore, it's not definable. So that's nothing. Like there's nothing that you can fill in here. It's not even a real number. Pi is irrational and real. Repeating decimal. Now some of the square roots are here to trick you because like on number 14, we know it's not a natural number, a whole number, an integer, right? Because we got some fraction, and I know that that fraction doesn't reduce into a whole number. But the square root of 4 is 2. The square root of 49 is 7. Well, that's a fraction, so that's a rational number. So make sure that you try and simplify your square roots because they might simplify into rational numbers. Number 8, negative the square root of 64. That simplifies into negative 8. So it's not a natural, it's not a whole, it is integer, which means I can make it into a fraction, negative 8 over 1. It's also real. Repeating decimal, let's do number 21. Repeating decimal, so therefore it's irrational and it's going to be real. 2/3, it's a rational number and real. 27, that's a natural number because it's a positive whole number. It's a whole number because it can include 0. It's an integer. I can turn it into a fraction, 27 over 1, and it's real. And we'll do one more. We'll do 22. It's a repeating decimal. I can't put it into a fraction, but it's still a real number.